Alright, today we're going to be doing radical expressions, and more specifically, we're going to be doing operations with radical expressions. So basically what that means is we're either going to be adding, subtracting, multiplying, or dividing. So let's take a look at these. Whenever we do these problems, what we want to make sure we do is we want to simplify first before we do anything. So the square root of 3 right here can't be simplified, but the 48 can. So let's keep the square root of 3 the same, and I can break up 48 into 16 times 3, right? 48 is equal to 16 times 3. So now the perfect square is the 16, right? So I can take the 16 out as a what? Well, what's the square root of 16? 4, right? So I can take it out as a 4, but the 3 has to stay on the inside. Okay, so now check it out. I have like terms. I have a square root of 3 right here with a 1 out in front that's assumed to be there, and I have a 4 times square root of 3. So if you think about it as, like terms, they pretty much are like terms at this point. I just need to add the numbers that are out in front. So what's 1 plus 4? That's going to give me 5, right? So that's going to be 5 square root of 3. And I'm done. Okay, let's take a look at the next one. Here I have square root of 63. I can write that as 9 times 7. And over here I have square root of 28. I can write that as 4 times 7. Okay, so let's take out square roots. The 9 can come out as a 3. The 7 has to stay inside. And the 4 can come out as a 2, since we're taking square roots. The 7 stays inside. So now we have like terms. They both end in a square root of 7. So we just have to subtract the numbers that are out in front. So 3 minus 2 is going to be what? 1. That's right. So you can write 1 times the square root of 7, or you could just write square root of 7. The 1 is assumed to be there anyways. Okay? Let's take a look at adding and subtracting with variables. What we want to do here is we want to simplify as much as we can first. First of all, notice that this is going to stay the same because you can't take the square root of 3. And over here, we can actually write this as 3 times 100, right? So let's try that. There we go. The x stays the same. And we can take the 100 out as a, what? A 10, right? Square root of 100 is 10. So this is going to stay the same. And this over here is going to become 10 on the outside. And I still have a 3x on the inside. And there you have it. We have like terms, right? So now we can add the numbers that are on the outside. 6 plus 10 is 16. Square root of 3x. That's it. I'm done. Alright, let's look at number 4. The 98, we can break that up into, what? 49 times 2? Let's try that. 49 times 2. And then the x squared is still there. Over here I have a 2 on the outside. And I can break up the 32 into 16 times 2. I'm pretty sure of that. Okay, so let's see what comes out. The 49 can come out as a 7, right? And the 2 has to stay on the inside. And the x squared can come out as just an x. Remember, we divide the exponents by 2. Over here, the 16 can come out as a 4. 2 times 4 is going to give me 8. And then the 2 has to stay on the inside, and the x can come out. Okay, so now we have like terms. They both end in a square root of 2. So we can subtract what's on the outside. So what's 7x minus 8x? Wouldn't that be negative 1x? So that's going to be my answer. Negative 1x times the square root of 2. Or you could just leave the 1 off completely and write it like this. Done. Okay, let's look at some multiplying. So right here I have 5 and 6 are multiplying problems. You can tell by the dot in the middle. So what you can do is you can simplify first or you can multiply first. The order in which you do things actually doesn't matter when we multiply and divide. So what's 5 times 10? That's going to give me 50, right? But everything is still under the square root, okay? So all I did was 5 times 10 equals 50. Now I can break this up into 2 times 25. I know that the 25 is a perfect square, so the 25 can come out as a 5. The 2 has to remain under. Alright, let's look at the next one. We can multiply first, or we can simplify first. For this one, I'm going to simplify first, but it doesn't really matter which order you pick. So when I simplify the 8, I know that 8 is 4 times 2. So I'm going to break that up into 4 times 2. I've still got the x cubed. And over here, I know that 12 is 4 times 3. Right? Okay, so now what's going to happen? The 4s are going to come out as 2's. So I'm going to have 2 square root of 2x cubed. Over here, the 4 is going to come out as a 2, and I have square root of 3x. So now the numbers on the outside can multiply to give me 4, right? Because 2 times 2 is going to give me 4. And then I've still got square root of 2 times square root of 3. That's the same thing as square root of 6. And then let's look at the variables. So I have 3x's times 1x. That's actually x to the 4th power. And then I take out as many x's as possible, and the way I do that is by dividing the exponent by 2. So 4 divided by 2 is 2. That means I can take out 2 x's. So that's going to meet the 4 on the outside, and the 6 is going to stay under. And that's all I can do. Alright, dividing problems. For these, you can simplify first, or you can just go ahead and divide. For this one, I know I can simplify the bottom, right? The top is going to stay the same. Can't really simplify 10 yet. 32 is 16 times 2. So I know for a fact that I get the 16 out as a 4. The top stays the same. Okay. At this point, what I can do is I can break up the square root of 10 into 5 times 2. So square root of 5 times square root of 2 on top. The bottom is still 4 times square root of 2. And notice what cancels out. I have the same thing on the top and bottom, right? So the square root of 2's are going to cancel, and I'm only left with 5 root 5 at the top and 4 at the bottom. Can't do anything else to that, okay? For the last problem, I think this kind of got cut off, but let me show you a trick you can do when you're dividing. You can actually put these under one tall radical, so that's what I'm going to do. 100x squared on top, 4x to the 4 on the bottom, and now I'm going to simplify on the inside. So what's 100 divided by 4? That's going to be, what, 25. X squared divided by x to the 4, that's going to be x squared on the bottom. So now I can break this back up again into square root of 25 on top, square root of x squared on the bottom. These are both perfect squares, so it actually works out pretty nicely. The top is going to be 5, the bottom is going to be x. Okay, that is operations with radical expressions.